Extraordinary claims require extraordinary evidence. The curiosity that leads humankind to search the stars for life outside of Earth has its roots in seclusion. Humanity's pride in its competence and its ability to observe and analyze faraway stars does little to betray the true and deep-seated loneliness that drives the search for extraterrestrial life. It is as though, secretly, mankind as a whole has a consciousness lamenting the fact that it can only share its proud accomplishments within itself and can only learn from its own experience. Therefore, humanity builds grand constructs to search as far into the universe as it can, hoping to find another civilization to quell the loneliness of an isolated existence. The Kepler Space Telescope, launched in 2009, is one of these constructs. It is essentially a photometer, a device used to measure the intensity of electromagnetic radiation. Kepler's designed to scan the galaxy in search of exoplanets, planets orbiting stars in a similar way to Earth. It accomplishes this by using its photometer to monitor the brightness of the stars it observes. If a star exhibits routine dimming, planets orbiting it could be the cause. Astronomers on Earth analyze the data from Kepler to determine if the stars had exoplanets orbiting them. However, the most interesting story told by Kepler data is not of the exoplanets, but of something much larger and more mysterious. A main sequence star designated KIC 8462852 exhibited strange fluctuations in light. Fluctuations that were unlike any other main sequence stars observed by Kepler. As of the last recordings made by Kepler, these fluctuations have remained constant, even now. The fluctuations go unexplained, and no hypothesis has been able to account for all of the strange aspects of the star's light curve. This perplexing phenomenon has caused astronomers to entertain the idea that something intelligent could be responsible for the strange behavior of the star. A star nearly 1,500 light-years from Earth that dims and brightens in unexplained ways that appear unnatural. This is the story of Tabby's star. Launched on March 7, 2009, the Kepler Space Telescope was part of a host of low-cost missions, which NASA called the Discovery Program. All the missions in Discovery were highly focused, with the idea that NASA would be able to use these funds efficiently. Programs like the Hubble Space Telescope and the International Space Station had been expensive when initially proposed, and their costs ended up far exceeding those initial expectations. With more specific small-scale applications of NASA's technology, cost estimates would be more accurate and the missions would be more sustainable. This is one of the reasons Kepler was operational far past its initial mission projections. By 2013, 2 reaction wheels responsible for aiming Kepler had failed, but its field of view was adjusted, and it continued operating until 2016. The simplicity of Kepler was genius. It would use its photometer to capture light intensity data from stars in a very wide field of view. Every 30 minutes, data was collected from roughly 150,000 stars at a time. After being sent to astronomers, the data was analyzed by both humans and computer algorithms. The main goal was to use the data to construct light curves, representations of changes in the brightness of a star over time. These light curves were then scrutinized to look for signs of planetary transit around the stars. Between its launch in 2009 and its retirement in 2018, Kepler observed more than 500,000 stars and discovered over 2,500 planets. In 2015, data from 2009 concerning one of these stars was observed by the Planet Hunters project, where humans were allowed to review the data from Kepler. The idea was that humans might pick up something irregular that computer analysis had missed. Examination of this star showed that it had an irregular light curve. The curve suggested that there was a transit of some kind occurring in front of the star, but further analysis only confused the data even more. Normally, a transit lasts only a few hours, but this one lasted nearly an entire week, suggesting that the object in transit was gigantic. Furthermore, the light curve was asymmetrical, seemingly indicating that the object in transit was not shaped like a planet. Scientists were unable to accurately identify the cause of the fluctuations observed. This star was KIC 8462852, affectionately dubbed Tabby's star, after astronomer and astrophysicist Tabitha Boyajian, who discovered the star's behavior in March of 2011. The brightness of the star was shown to drop by an incredible 15%. For reference, a planet the size of Jupiter would only cause a star like this to dim by 1%. The dimming lasted almost a week, but then the star returned to normal brightness in just a few days. In February of 2013, a massive drop in brightness occurred in Tabby's star, followed by a series of dimming events that would last over 100 days. These final dips in brightness were highly varied, some being smooth and quick, others rough and lasting over a week. Analysis of the trends of dimming and brightness during this period seemed to dictate that there were many transit events occurring simultaneously. Incredibly, the brightness of the star during this event was shown to have dropped by over 20%. This would indicate that whatever was in transit around Tabby's star was roughly 1,000 times greater in area than Earth. Many explanations were put forward to attempt to explain the strange behavior of Tabby's star. First, it was assumed to be an error in the data. Astronomers combed through the information expecting to make corrections, but to their surprise, no errors were found. The ensuing analysis led scientists down a cyclical path of proposal and dismissal. It was hypothesized that perhaps Tabby's star was young and surrounded by an uneven ring of dust and debris, or a protoplanetary cloud left over from the nebula it formed from. However, there was no data to suggest that the star was young, and if a protoplanetary cloud were present around it, there would be a glow observed due to the star heating the surrounding dusty material. Another explanation suggested that the fluctuations in brightness could be caused by a massive swarm of comets, whose solid mass and vapor trails were obscuring the star as they passed by. This hypothesis, however, was also deemed unlikely by astronomers. The swarm of comets would have to number in the tens of thousands to produce the 20% drop in luminosity observed. Other hypotheses have been proposed, but the uneven debris ring and the swarm of comets are the most suitable natural phenomena that could explain the star's behavior. There is, however, another proposed explanation for the fluctuations in luminosity observed in Tabby's star, one that is entirely more interesting and controversial. Tabitha took her findings to SETI, the search for extraterrestrial intelligence, to rule out the possibility that Tabby's star was surrounded by an alien megalithic superstructure, a Dyson swarm. According to a hypothetical hierarchy of extraterrestrial intelligence called the Kardashev scale, there are 3 types of alien civilizations. Type 1 civilizations can build structures that harvest the energy of their planet. Type 2 and 3 civilizations, however, can harvest the energy of stars themselves by building incredible structures around them. These theoretical structures, often referred to as Dyson spheres, Dyson swarms, or Dyson constructs, would need to encompass the star and would likely create strange fluctuations in the observed luminosity. The minutiae of a Dyson construct would have to be hundreds of times the size of Earth. Thus, it was proposed to SETI that perhaps Tabby's star was host to a Dyson construct. When news of Tabitha's proposal was leaked to the press, it took the world by storm. Suddenly, there was a deluge of articles on the subject, and artist renditions of massive Dyson constructs proliferated on the internet and in the news media. The most compelling thing about Tabby's star was that it was such a new discovery. Even astronomers were scratching their heads, and the natural explanations for the strange light curves were tenuous. Tabitha Boyajian said it herself in a TED Talk on the subject in 2016. Extraordinary claims require extraordinary evidence, and it is my job, my responsibility as an astronomer, to remind people that alien hypotheses should always be a last resort. And here, that seemed to be why aliens were being considered. Though there were no definitive answers to prove that it was caused by extraterrestrial intelligence, the fact that mainstream astronomers were proposing the idea of aliens was more than enough to pique the curiosity of the public. In a brief moment, humanity could finally let its imagination run wild. For what may have been the first time, there was a true possibility that humankind had found another civilization like itself. Moments like these reveal the loneliness felt by our species. Humans forget about their problems, the mundanity of their daily lives, and look up to the stars with a new sense of society. Inevitably, there will be those who would fear the discovery of alien life. But based on the reaction to Tabby's star, it would seem that most are excited by the prospect. Excited that one day humanity may share its accomplishments with a new companion, that it may learn from the experiences of a civilization that evolved far, far from Earth, that our planets could aid one another, building a sense of partnership among the stars. In its solitude, surrounded by lifeless balls of rock, ice, and gas, humanity is inspired by the possibility, however unlikely, that it is not alone. Thank you for watching and listening. If you liked this video and would like to see more like it, please hit the like button and subscribe to my channel.